Hello everybody, my name is Howie Reith, and today we're going to be talking a bit about React State Management. This is going to be the first video in a series on the topic, and we are starting with React-Redux. For those of you who don't know me, I'm a software developer. I'm a big fan of becoming as good a software developer as I can be, as quickly as I can be. And teaching in these videos is part of how I am doing that. Feel free to leave a comment with questions or email me if you have questions there too. So what are we going to cover? First, what is Redux? I imagine if you're coming to this video, you've at least been exposed to it, but we're going to go over some of it in depth. Then we are going to build Redux. We are going to build our own Redux state container using the exact same method that Redux uses. We are then going to implement React-Redux in the same app, and then go over whether or not Redux would be right for your particular use case. So what is Redux? Let's do a little history about React. There were a variety of UI structures that we're developing. You might have heard of Model View Controller, Model View Intent, Model View View Model. Going over those is beyond the scope of this presentation, but be aware that there were a variety of different structures to web UIs that were being discussed, mostly based on desktop user interface structures that came previously. When React was first developed, it did not have a mechanism for keeping track of model or intent, or state, basically. It did not have a mechanism of tracking its own state. It only provided the view, and you're probably familiar with the view in React as your JSX code, the code that compiles into HTML and generates the web page that is your application. Around this same time, there was this pattern called Flux. It's a state management pattern that was rising to prominence in the desktop UI world, one we're going to discuss very shortly. And so be aware that these things were developing concurrently, and there was a lot of conversation about how do I, as a web developer, structure my user interface? How do I keep track of user actions? All of these sorts of questions that were going around and people were trying to solve. So let's go over some vocabulary here to understand the conundrum. So we're going to talk about model view intent in particular, as this is a popular structure and more or less the way we can be thinking about the way our UI is structured. In reality, React is probably more appropriately described as model view view model, but when we're bringing in Redux, I think having the idea of the intent is a lot more useful to us for understanding this pattern. Now, when we think of model, whenever you instantiate a component in React, you have that little object that says like state equals open object and then all of your properties in there, right? That is your model. The model is the state. It is the object that holds the source of truth for the data inside of the system that you're keeping track of, okay? That is your model in this context. The view is the rendered UI. Like I said, in the case of React, it's your JSX. It is the user interface that is being generated, and what it does is it accepts a model, right? Every time the model is updated, you are generating a new view that is affected in some fashion by the update to the model. And then intent, these are your user actions, your system events, things like that, the things that interact with the model and alter the model, resulting in the changed view. Now, it's important to note that React, and this system in general, is a state machine. You never directly modify the model. What you do is you take your intent, the changes that you are making to the model, and you generate a new model. You clone the model, you make all of the changes according to the intent, according to the actions, the modifications you are making, and then you return a new model. And then that new model is accepted by the code that generates your view, and then the view is updated. React performs a re-render of your web page. So keep that in mind. This is a state machine. We are never directly modifying the model, the state. We are accepting an intent and then creating a new model based on the changes that it makes. So now that we understand MVI, let's talk about the Flux pattern. The Flux pattern splits an application into 4 parts: the store, dispatchers, views, and then actions or action creators. So store is where the state is stored, both the domain and the user interface state. State is the data value itself, the information that matters. The store is the object, the structure in which that state is being stored. Okay? So just think of it that way. It's the storage of the state. There are no setter methods on the store. Like I said, for React, we are operating with a state machine. Here in the Flux pattern, again, we are operating with a state machine. You can only update the state that is in the store by passing an action to the dispatcher, which we're going to go over shortly. Now, the store is listening for all of the actions, and it has logic to figure out how to handle the various actions, the behaviors that are passed to it. And usually this is a switch statement or a bunch of ifs or something along those lines, right? And then when the store has made a change, it emits a change event. And this is what's called a publish subscribe model, which we can go over a little bit more when we talk about the remaining pieces of the Flux pattern. So next is the dispatcher. The dispatcher is a single object that broadcasts actions and events to all registered stores. So when you first create your application, you're going to register all of the stores. Let's say I have a banking app, right? This is the store that contains data concerning bank transactions. This is the store that contains all of my state concerning user stuff. Okay, so you have a combined state, a combined all of the state in your application, but you're usually going to be splitting it up into a variety of little stores that are concerned with specific things in your application. So the dispatcher broadcasts actions and events to all registered stores, particularly when those stores are concerned with the events that is being dispatched. So when an action comes in, it passes that action to all the stores, and then the stores deal with them appropriately, modifying the state. So the view is just what we talked about before. In the case of React, it's the JSX. It is your actual manifestation of the user interface, right? So the views are listening for changes in the store, they're looking for changes in the state, and then they re-render when those changes have occurred. And also keep in mind that some parts of the view can itself dispatch actions that will update the state that is in the source. So for example, obvious case, a user clicks on a button that is going to have some sort of effect, right? So a user interacts with the application. This issues a dispatch event that is going to make a change to whatever is being stored in that relevant part of the store. And that results in a change to the application's behavior, right? It results in a re-render of the UI. Say, I type some information, I click submit, that action causes a change in the application that results in a new appearance on the screen, right? This interact in this sort of way on web applications all the time. So lastly, we have the actions. Actions are more or less synonymous with intents, what we just talked about in model view intent. So actions are plain objects that contain all the information to perform that action. They typically have a type property that is identifying the type of action that they are. And they typically come from views or from initialization code, or if you have a timer that sets them off after an hour, something along those lines, right? This is the actions that alter the model in some capacity, okay? So let's talk about a little bit more history here. So React is going along, and then the Redux library, which isn't only used in React, by the way, it's used in a variety of purposes, but Redux implements the Flux pattern. And people who are using React look at Redux and go, hey, this is a way that we can be keeping track of our state inside of our React apps. Finally, we have a way we can do this. Fantastic. Now, shortly thereafter, the developers of React come out with Component State API. And this is the sort of state tracking that you are probably familiar with when you set state inside of your class component, or when you use state inside of your functional components with hooks. This is what you're using. You are using the Component State API. It is a way of keeping track of state inside of your component. Now, when Component State API first came out, and Redux was already relatively popular and in use, people looked at that and were like, oh, this isn't functional, and we have this nasty prop drilling problem where if you have distantly related components, you need to pass these actions all the way up and then have the data passed all the way down on the other side. And that's really annoying to this day. That is really annoying. So a lot of people were like, this is pretty lame. We don't actually want to be using this. We're going to keep on using Redux. Now, as people continue to use Redux, they grow frustrated with some of Redux's downsides. It's a really complex solution. Do you really need to have a publish-subscribe model just to be passing data to distantly related components in your application, right? It's also really opaque. It has an issue where you have your dispatchers and your components and your stores, and they're all split into these different places around your application, and it's not always easy as a developer to look at the code and understand how the flow of data is moving across your application. Or if a particular piece of data is updated in one part of your application, how is that going to affect other parts of the application? There's also some anti-patterns that became in wide use that we'll talk about toward the end of the video. But suffice to say, there was a lot of frustration that was brewing with Redux as well. Thus, factions began to form in the community. One group developed MobX, and MobX started to become really popular. And then React implemented the Context API, which was a built-in state management tool that could be used to bring state from distantly related components to a pseudo-global level without putting everything to the highest level, right? It was a very elegant, simple solution to the problem. Now, after that came out, consensus started to build that component plus context API solved the vast majority of state management problems that React had. And since it was baked into React, a lot of people were like, oh, maybe we don't need these external libraries after all. But of course, some people still preferred them, and that debate is ongoing, right? I'm not going to try and pretend that's not the case, but a consensus was brewing that vanilla React wasn't as limited in terms of state management as it was once complained to be. Also, more solutions even after that came out continued to be developed, one of which is unstated, and many, many, many more that I probably won't have time to address even in this entire series. But anyway, so my opinion and my mentor's opinion, this is how 5 of the biggest state management solutions for React play out, right? React State API, this is just your component state, right? This is the simplest solution. All you're doing is passing props and monitoring state inside of the components. That's all you're doing. Obviously, that has drawbacks, prop drilling, and so on. A little more complex, React State API, the component stuff, plus context. You can wrap context around the components that you need to have access to your relatively global state. That's pretty cool. Unstated is a little more complex than that. And then at the far side, at the most complex end of the spectrum, we have Redux and MobX, which are complex in different ways. Okay, so in order to understand this all a little better, let's build Redux. Okay, we are going to build our own Redux-like state container, so that way we deeply understand exactly what Redux is doing under the hood. On your terminal, clone the following GitHub. If you want to go to my GitHub, it is just Howard Reith or github.howardreith.com/redux-demo. Or you can just copy this git clone right here. It is going to clone 2 projects into the folder that you clone it into. One of them implements Redux. One of them is going to be for our state container here. We are going to be going into the state container folder. Go ahead and install all npm dependencies, and then as soon as that's installed, go ahead and run npm start. And then if you go to localhost 3000, you should see a pirate tic-tac-toe game loaded. And that is what we are going to be using or building with our state container. All right, so here is our pirate game. Okay, we have just the board. All we're doing is playing tic-tac-toe. You can play it just like you would expect. And there's a few things that we're keeping track of in state right here. One is we want to keep track of the current state of the game board. What values are in each of these squares on this game board? Next, has anybody won? And if so, who has won? We want to keep track of that as well. And lastly, whose turn is it? So we aren't getting the wrong item being added to the incorrect square or whatever else inside of our game. Okay? So how are we doing that? So if you go into the code, take a look at this store.js file. You will see here we have create store, which is a function that does exactly what it sounds like. It is going to be creating our store. Now these 13 lines of code right here, basically this is Redux. There's a little bit more the actual library gives you. I would not suggest foregoing using Redux at all if you want to use it and using this instead. I'm not suggesting that. But for the sake of understanding Redux, these 13 lines of code are essentially everything that Redux does for you. This is how we are keeping track of state inside of our Redux container. So let's have a closer look here. So you'll notice that create store accepts something called a reducer and a default state. And we have this value here called internal state that is being set to default state. So internal state, this is our object that is keeping track of our state inside of our Redux container. This is what it's all about. This is the model that we are occasionally going to be updating. And then handlers is something we'll talk about very shortly when we talk about the subscriber pattern that we do below. So have a look here. Dispatch. Dispatch accepts an intent, which we can also think of as actions, and it sets the internal state value that we have in here based on the value that the reducer that is passed in returns when it receives our model, our current internal state, and the intent that is acting upon that model. Now let's get an example of this so we can help wrap our minds around it. Let's go to this statecontainer.js file. So you'll notice down here, we are setting a global variable. If you watched my JavaScript video, one of the things I suggested was never use var, right? You're only ever using const. But here, we are deliberately using var because we actually want to be hoisting this container up as a global variable, okay? And this container is going to be the result of when we create store. And here is the reducer that we are passing in, this update function here. So notice that update accepts a model, like we were talking about, and the intent that is going to be acting on that model. And it sets an action equal to what the intent is. Now notice, so the way this is set up, we have a finite list of intents that we will accept as valid intents in our application. And the only two intents that matter are the play and reset game. So we are going to say, hey, our action is equal to, you pass in the intent, tell me the type of that intent, okay, I'm going to grab this one. So action is now equal to whichever one of these two functions it has chosen. Let's just say, for the sake of discussion, it's reset game, okay? So we now have reset game is being called with our current model that is being passed in and the intent. Now reset game doesn't actually care about the intent, but what it does care about is the model. So it's going to spread the model. And remember, in JavaScript, when we are doing this spread operation here, we are taking the entire object that is being passed in there and we are making a clone of that object. This is not the same object. The thing that is being returned here is not the model, but modified. This is a clone of that model. And that clone is being updated with the following values. Game board is going to have empty board, which is just a nulled out board coming from our helpers functions. And winner is being set to null. That is what is being returned. Returns right here. Update returns right here. We go back into our store. Our dispatch right here returns it as well. Internal state, which is being set here originally, is now returned. So the reset game has set our internal state to have that nulled out value and resets the entire game, which was why our reset button here works the way it does. So I hope that all made sense. Feel free to rewind the video. I know this is a relatively complex thing, but hopefully you were able to follow all of the logic, the pattern that was going on there. So moving on, let's talk about this subscriber pattern that is happening here. So you'll notice here we have an array of handlers that is also inside of our create store function. And we have the subscribe function. And subscribe is a function that accepts a handler and simply pushes this handler function into this handlers array. Now, every single time we do a dispatch, that is, every single time we perform an action that is going to be updating the Redux state, the state that we have inside of our store here, we are also going to be calling every single function that is inside of our handlers array. So this is the way that Redux hooks into React's rendering functions. What is going to happen here is that a function that calls the render function is going to be called every single time our state is updated, thus informing React, hey, the state that I have in Redux has been updated, you'd better re-render so that way the model that I have in here is now being accurately reflected by the UI that you are rendering. Okay? So, every single time we perform an update to the model in Redux, we are also performing a re-render on every single component that has subscribed to our Redux store. And then the last function we have in here is this getState function. All this is doing is returning the current state as it exists inside of Redux. All right, y'all ready for a magic trick now? So go into your package.json and add in these guys inside of our state container repo. This is React-Redux and Redux. This repo is set up to be compatible with 6.0.1 and 4.0.5 of React, Redux, and Redux respectively. I cannot guarantee it will work with a more recent version of either of them, but it very well might. But in any case, go ahead, add those in, do an npm install, and then head over here to state container. And instead of doing create store from our store file, we're just going to make one tiny little change. And then once that's done, go ahead and go into your terminal and restart this if it hasn't done it automatically. And voila! Is it going to work? Yes, it does. So Redux works just the same way. We could make that change, and now it is using the Redux library instead of our state container, and it is working like a charm. All right, so now that we have experimented with building our own Redux-like container, let's see about implementing React-Redux itself. So for our purposes here, you can use the other project that is inside of the repository that we cloned at the top of this presentation, the actual React-Redux project. Feel free to do npm install and npm run start to get that one going and up and running before we talk about it here. So just like ours, React-Redux provides a provider object that must be wrapped around the highest level component in your application. And just like ours, it accepts a default state container as a property. So just taking a look at the code, if you go into index.js, you can see right here that we are importing the provider from React-Redux, and we need to set the store equal to create store from Redux, just like we just had, and we are going to pass in a reducer, which we have added to a new reducers folder here, and default state. Now note, you don't necessarily have to do this, but the presumption is that as your program expands, you're going to have more and more reducers. So you probably want to be keeping track of your reducers separately inside of its own reducers folder, like so. But just for the sake of our understanding here, this is not particularly more complex than the reducers that we just had in our previous example. Continuing on, we don't need to worry about the subscription pattern, the subscriber pattern for rendering, because React-Redux takes care of that for us. Now, actions are generated through action creator function, and they are passed to the Redux container's dispatch method. So that is another thing that we ourselves don't necessarily need to deal with, though we'll talk about how we deal with that in just a moment. So as you could see from that file we took a brief look at, our reducers look more or less the same as they did in our custom container. Remember that no reducer should ever be modifying states directly. It should always clone, update, and return a new state. Keep it a state machine. Reducers are combined in React-Redux's combine reducers function. So every single reducer that is passed to this function is going to be managing just a portion of the overall application state. So just the things that this reducer is concerned with. Now the main service that is provided by React-Redux, that is in addition to the stuff that we already talked about in our custom Redux store, is the automatic connection of components to application state. And this functionality is achieved via two functions, map state to props and map dispatch to props. Now React-Redux's connect function accepts these two functions and returns another function that accepts a component and returns a connected component. And that connected component is now a component that is connected to the Redux store, the state inside of the Redux store that it is particularly concerned with. It is subscribed via the subscriber pattern, its render is taken care of, and all of the state that it is concerned with inside of the Redux store is now going to be passed into that component through its props, and it is going to have access to that state via the dispatch. Now when the app changes, React-Redux maps the new state to the props of the connected component and re-renders that component for us. Let's take a quick look at how that's being done. So down here inside of pirate-tic-tac-toe.js, you'll see that connected pirate-tic-tac-toe, which is what we are exporting from this file, remember, has the connect function, which is imported from React-Redux, and we are passing into it map state to props and map dispatch to props, which is what we are defining here. Map state to props consists of an object that is going to have the state that we are concerned with, the game board, the player, and the winner. And then map dispatch to props has the functions that we are concerned with that are going to be running, that are going to be updating the model inside of our Redux store. So on reset game is going to be resetting the game via our helper function right here, and so on. Just to clarify one thing, I've added a console.log of props to the Pirate Tic-Tac-Toe board, and here you can see we have game board, on play, on reset game, player, and winner coming into our props in this component now. And those are all of the props that we are setting inside of our map state to props and map dispatch to props functions that are being injected into it via React-Redux. Alright, so final section. Should I use Redux in my application? Probably not. Probably weren't expecting me to say that, right? Why would I spend all of this time to learn and teach a tool that I wouldn't recommend? It is not that I wouldn't recommend it, okay? It is a fantastic tool for the job it is built for. Redux is a complex, opinionated, niche tool that is extremely well designed for situations in which you need to track state and actions across the front end of your React application. Unfortunately, that is not how it is most commonly used. Keep in mind the history of state management in React that we talked about at the beginning of this video. Redux was filling a state management void that was present in the React world. It was just about the only thing that was available to fill this role. And as such, a lot of people just used it by default. The idea of using React without using Redux is a foreign idea to a lot of people. It's like, how on earth would you even do that? It doesn't make any sense. And consequently, the idea of using React without using Redux, whether or not Redux is the right tool for the job or not anymore, is completely foreign to people. They use it simply by default because it's what they learned. It's the proper way to do it in our business. Just because something is popular and in wide use does not mean it is right for your application. You are an engineer. You need to make this evaluation on a case-by-case basis. And simply put, you have so many more options now at your disposal, many of which are far simpler and far more universally applicable than Redux is. So most of the time, what you want out of a state management tool is something to supplement component state. You're getting tired of needing to push events all the way up to the top of your application and sending the data back down from the top level to the distantly related components that need that data, right? You need something that you can just transfer the state into and have it available when you need it available, preferably without shoving it into a global variable just in JavaScript or in local storage in the browser or something like that, right? Well, Context API does that very, very well. And that is available to you now in a way that it wasn't available in previous generations of programmers using React. You don't need an elaborate publish-subscribe model just to pass state to distantly related components. So, furthermore, generally speaking, you want to keep state as local as you can keep it. Keeping your state stored inside of the components that are directly concerned with it keeps your components modular, makes them a lot easier to unit test because you don't have to be pulling in a whole bunch of arbitrary state that your component's not even using just to get it to render. It makes the code easier to comprehend because everything that you need to worry about is right here inside of this component. And if I change state inside of this component, I don't need to worry about it updating something else on the other side of my application. I mean, that's what we all hate about CSS, right? That's why it's so important to be disciplined about how you do CSS. When you introduce something like Redux, you have to be very careful and very disciplined in how you use it. If you don't implement Redux, you're sort of bowling with the bumpers on, right? There's only so bad you can get. And if you design your application poorly and your state management poorly, you suffer the consequences for it immediately. You have to deal with the passing of the props and the state all the way down through the various components because you did a crap job of designing your application. If you have Redux, the consequences of your bad design decisions probably aren't going to be truly felt for a year or two down the line when some other poor developer is trying to figure out how all of this state maps to the different parts of the components and they're going insane trying to figure it out, right? So keeping everything inside of the components, keeping everything modular, just makes your code so much easier to maintain and understand and test and all of the good stuff that makes us happy, competent devs. It's also worth noting that many people who use Redux commit several anti-patterns, the most egregious of which being they connect all components. Oh, I'm using Redux. This is my state management solution and it's the only one. I guess every single component that I have in my application needs access to state and needs access to all of the state. Okay, that is probably not the case. Remember, you want to be keeping your state as localized and specific as you can. You don't want to just be having arbitrary, global, generalized state variables that are just accessed by everybody, because then your application evolves into this massive blob of ambiguity. You want to have it modular and specific. People are also sort of in the habit of designing reusable components that are supposed to be located in multiple parts of the application, like a field that you might be using in many different forms, right? But they bring Redux into it and they're injecting all of the state in there, and suddenly this component that is supposed to be modular and reusable is now dependent on global state and expected to be using a particular part of global state. Thus, it's not reusable anymore. You have eliminated the benefit of your design. By virtue of the way that Redux does things, you're also encouraged to split actions, reducers, and components across many different files, and that alone can make it a bit more difficult to follow. Here are some quotes. This is from Pete Hunt, one of the original developers of React. If you aren't sure that you need Redux, you don't need it. And then Dan Abramov, one of the original developers of Redux. Don't use Redux until you have problems with vanilla React. Okay, so I have hated on Redux a lot, but like I said, it is a very good tool for what it is designed to do. So what is an appropriate use case for Redux? Well, anytime you have a use case that is specific to Redux's unique features that aren't provided by other state management solutions. For example, if you really care about time travel, if you want to be able to be looking at all of the events of a particular user who has been going through the application and interacting with it in a particular way, and you want to be gathering data about that, and you want to be able to recreate that user's experience across the entire app, Redux can be very helpful for doing that. Likewise, in the same way, it is very good for an undo functionality. If you need to be monitoring snapshots of state as it changes across various interactions with the app, Redux can be very helpful for doing that. So essentially, if the core functionality of your application involves monitoring user behavior, for example, if your Facebook and all of your revenue is generated through targeted advertising and you need to be watching exactly what your users are doing in order to target ads at them and make your ads as effective as possible, then yes, Redux is an excellent tool for your particular use case. If that is not you, if you are just building a general application, you probably don't need such a complex tool and all of the overhead that comes with it. Thank you all very much for watching. I hope this was helpful for you. As always, this presentation, the PowerPoint for it, is going to be available on my GitHub in a link in the description. You can access this bibliography through that PowerPoint, and I encourage you to do so. All of these folks know way more about this than I do. This presentation was overall based on a section of the Rating React presentation by my mentor, Dale Allishouse. I highly encourage you to check out the wiki on that. And also feel free to clone or fork or whatever else the repo that I made for this stuff to do your own experimentation and play around with it. Again, if you have any questions, feel free to email me, feel free to comment on this video. Very happy to help you out any way that I can. So thank you, and have a good one.